Okay, I'm going to start by doing letter A on the back of the blue sheet, which I'm right here. I went ahead and recopied it onto a separate sheet of paper so it was easier to read. All right. Anytime I have a vertical problem, I have to take into account the weight. So this force here is going to be the weight. I'm given the mass, but I can always find the weight from the mass using the equation Fw equals mg. And that's how I can go back and forth between the mass and the weight. So this little side step here, I've got my mass is 51 times 9.8, which is g, and I get 500 newtons is my weight. I'm going to write that here, so it's real easy to find. So I'm going to have this little side bit on a lot of my problems. Go ahead and fill that in my free body diagram. Now I can sum the forces. So sum the forces equals the mass times the acceleration. When I sum forces, it's just like math class. This is a sigma. And I'm just going to write down all the variables I have with the appropriate positives and negatives. Ft is pulling upwards, so that's positive, minus Fw, the weight, it's negative because it's going down, equals m times a. And then I'm going to plug in the numbers I have. Ft is 1200, Fw is 500, the mass is 51, and then a. Over here, I get 700 equals 51a. This side of the equation, up till here, this is your net force. Sometimes a college prep level question might ask, what is the net force? This here is equivalent to the net. So in this case, if it just said, what is the net force? The answer would be 700 newtons. So that's a sidebar. Keep solving. And I've got A is equal to 13.7 meters per second squared. Don't forget your units. Notice that it is unbalanced in the upward direction, so it is going to accelerate, and it'll accelerate in the upward direction.